says yes, what you're doing using ArcGlobe now will work in CityEngine, but the bad news is it's not working in CityEngine quite yet. I know there'll be another release of CityEngine coming up in the spring, so the intent is to do just what you said, but you can muscle it to get it to do what you want. It's just not easy right now. The other exciting thing, well, a couple of things you need to know with Esri at least. Right now, I have to download the whole file in CityEngine, so you got to wait, let's say, 5 minutes to get that model to show up. They are developing a streaming version instead that will bring it up right away. And that should have been released this month, and now they're saying in the spring. So obviously they have a lot of work to do. And the last thing, does anyone in here use SiteOps at all? Is anybody familiar with that program? SiteOps is probably the closest real-time modeler that I've seen out there. And what it does is it creates, for example, I'll pick on a Walmart site, and you inlay the terrain model in the SiteOps. And what it does is in real time, it'll calculate things. For example, if you move a road to a different area, it'll recalculate the cost of the cut and fill for that in real time. And Esri has a partnership with SiteOps now, and it's a great modeler, a conceptual modeler, and that ability to really manipulate the terrain inside of an Esri application is exciting for me. So I'm going to shut up and let Kevin go.
Cool. I showed these yesterday, just quickly again reminding people that the Everyday Count initiatives has language in it referring to GIS and to 3D models, 3D engineered models, with the incentive that projects could gain additional funding by using these tools. So I think at the federal level, there's definitely incentive to use some of these tools for projects. I just wanted to start again, probably reiterating some of the things Chuck has said. You know, this is kind of our really basic set of guidelines that often we find, you know, ourselves trying to get this put into BIM specs. You know, BIM specs for 3D modeling seem to be all over the map in different places. But, you know, the first and foremost is to establish a coordinate system for the project. Is it a project-based one? Is it something you want to be city-based? You know, with projects, it's typically going to be state plane. Some of these tools prefer more geographically oriented systems. We do a lot of modeling in 3D Studio Max and Revit, which are single precision systems, and they tend to like to be near the origin, not out in state plane space. So we establish a transform right up front and document that so that everybody understands what coordinate system they're working in any product that they're using. Model organization is key to get established up front. Naming conventions. You know, is it a design model? Is it a construction model? Those have different needs and different types of naming conventions that you're going to want to establish. If it's a 4D simulation, you got to deal with the schedule, because typically the schedule drives naming conventions. So, you know, you got to understand who's doing the schedule and make sure they're using naming conventions up front as well. There's so many times we've gotten schedules where every activity is just form, rebar, you know, form, pour, with no designation of the actual location or object or where it is. Roles and responsibilities. Is there an overall modeling manager? We're seeing that role established on a lot of big projects now. It's typically 1 or 2 full-time equivalents. Somebody to just manage all the data, to bring collaborative models into meetings and help facilitate meetings. Even though I'm jumping back to BIM, you know, this really is kind of driven a little bit by the use of 3D GIS data. You know, it's the GIS world that's really sort of pushed us into this consistent coordinate system approach to projects. I'll talk a little bit about some of our work processes. We're typically supporting a design or construction process. It's not so much we're building huge data-rich models. We're building models that help support the communication efforts both internally and externally. A great tool we love is Global Mapper. It's a great way to surf for free data and then to tile and collect that data into more kind of consistent, easier to use ways. It's it's kind of Esri Light, we call it. So, but for every project, virtually every project we do, the first thing we will have somebody do is go out and find the highest res aerials, the most recent aerials they can find, and some kind of terrain. and then we will typically tile it in a consistent way. The reason we do that is if your aerials match your terrain tiles, you can use those as mapped objects in other products that aren't so geospatially aware. 3D Studio Max, for instance, I can create a texture map terrain as long as my aerial matches my terrain model. So again, that's our first step. Tile out the area, get these aerials and DEMs in place. Chuck mentioned a couple of sites. The two that we probably use the most for these, right up front if there's no project data, USGS has a graphically driven portal where you can get some pretty good DEM and aerial data and some vector data too for certain locations, the national map. WeoGeo, I just like the name, but it's a lot of their data you have to pay for, but a lot of it's not that expensive. It varies a lot all over the place in what's available. So I was going to talk about a couple different types of environments we use this data in. We still consider it 3D GIS data, but again, if you do it correctly, that data can be shared amongst several different models. So even in Navisworks, we will typically try to incorporate that existing terrain and existing aerial data just to create a context around our projects. So I thought I'd show an example of that. Try to do as many demos as we can. This is a Navisworks model that we did for just a simple little LRT structure, which is crossing over a highway. And I am theoretically in, there we go. It takes a minute for it to kick in. Wow. I think PowerPoint is becoming more and more of a memory hog. Well, you can see this has a lot of formwork detail in it, so it is a pretty big model. But by taking that little bit of time to get this context in, the clients and the folks who don't know the project that well, whoa, we're better able to understand where we are in space here. Let's go to a predefined view, and then we can run a little simulation here. It's a 4D model being driven by a schedule, green for construction. I don't know that we have much demolition here, yellow for temporary stuff. A real small 100, I think it was a few hundred activities. But we were able to put this model together in less than a week. So, these little, using this available data can tend to expedite your flow and give you a rich model in the end. So I'm going to talk about a couple of other models. Of course, I'm running InfraWorks in the background too. That probably isn't hurting anything, but I showed the San Francisco model yesterday. I just want to talk in a little bit more detail of the kinds of data we're bringing into this model. This was kind of an experiment for us to see just what we could get away with and really push the tool. We're using USGS data, as usual, terrain data for most of the surrounding areas. For the city, they had some higher res ortho aerials, which we were able to acquire from them. They had street center lines, which we brought in and did a few custom street objects for, and I think I said yesterday that we have trees, and some of the trees are being placed based on vector data from their geospatial data set, so the trees are in surveyed locations. We also generated a lot of custom 3D data for this model. We had a max model of San Francisco. We took a lot of that data for the downtown area, converted it and translated it into a coordinate system that could be brought into the San Francisco model. Street furniture, we have some light poles, some other things. We brought in two of our larger projects, the San Francisco-Oakland Bay Bridge model that was in Max and a Presidio Parkway model. We did experiment a little bit with bringing CAD data in. I'll show another model where we were able to do that. So somebody asked about the area you can cover. That is one thing we found pretty nice about this. We were able to model a pretty large area in InfraWorks. This is a shot of downtown. Again, most of these buildings are 3D Studio Max models exported as FBX and then brought in and placed through a translation system. What else? There's some trees here. The trees were actually built in Max, exported, but then we created InfraWorks objects with them so that they could be placed in InfraWorks. So you can create custom 3D content that can be automatically placed in models as well. So there's the Bay Bridge model. I'll run this model when I get done with the slides rather than try to jump in and out. I think that's probably causing part of the problems. I showed this little scan yesterday because this is geo-referenced and LiDAR data is typically geo-referenced as well. With the new ReCap tools, these come right into InfraWorks. In location, you can animate with them. The engine is pretty smooth inside. InfraWorks, the ReCap engine is now in all of their infrastructure tools. AutoCAD, Max, InfraWorks, and Navisworks. This is another project where we tried a smaller scale project. Same kind of workflow. We got a local aerial, we got a terrain model, and then we built some of the civil structures in AutoCAD, Civil 3D. So here we've got USGS aerials, terrain data. We had some data from the County of San Mateo. We built the existing road network around the interchange in Civil 3D, and then we also developed several alternatives that we were proposing in Civil 3D. We also created a LiDAR scan, or captured a LiDAR scan of the overpass. The underside of the overpass was sort of the critical design element, the width of the pier to abutment and the height of the overpass. We also brought in some trees and vehicles from 3D Studio Max. Oh, I'm sorry. ReCap is an Autodesk tool. It stands for reality capture, but it's actually now two products combined, but the product I'm talking about is their point cloud management tool. So it allows you to bring in point clouds, carve them up, optimize them, and then export them in a format that can be loaded into other Autodesk products. So here's one design that was created, a sort of diverging diamond option under the overpass. One thing that we often do, we take the aerials that we get from other sources, and to make models look a little bit better, we'll often bring them into Photoshop, paint them up, export them out, and then we can swap between the aerials for different alternatives. In this case, we had to paint out all of the existing overpass and roadways and ramps so that when we brought the Civil 3D model in, it wasn't sitting on top of an aerial with the existing condition in place. And then we can bring in some trees and stuff. Again, it's a planning level tool is how we're seeing it being really useful, so you can do this really quickly. Yes?
How do you do with the georeferencing when you go from Photoshop and then come back?
Well, as long as you have a tiled aerial, you're just replacing the old one, just rename it. The quick and dirty way is to have two folders with the same names, and then you just redirect to the other folder. But if you bring them both in with different names, then you can swap between them interactively. So, but once it's geo-referenced, it's always geo-referenced. This is another alternative using a slightly different trick. You can also do a cutout of a terrain model. So here we're cutting out the aerial and just placing a green sort of shading over the other roadway alternative. And all the roadway models, again, were developed in Civil 3D and just exported and brought in directly into InfraWorks. We also, as I said, captured a point cloud. This is just a little video captured out of InfraWorks showing the point cloud popping in and then zooming around to see it. So we were able to, in a half day, we used a vendor for this, but he did, I think, 10 scans in a half a day. It was a mess, and I'll show an animation in a second that showing what the cloud looked like before we cleaned it up a little bit, but we used ReCap again to just carve out all the artifacts that were there from cars going by and people in the scene. Yeah, so this is an animation from the ReCap interface itself. So here you're seeing, I'm just driving around the cleaned up model, and I think at some point I have a slide of the pre-cleaned up model. It's a fun little tool. Bentley has similar tools. They have their point tools suite, which does the same thing. You can carve up the point clouds, save them in a certain format, and it can be loaded into V8i. And you can measure in them. You can do all sorts of things. Again, as long as you ask your vendor to provide the cloud in a known coordinate system, the data is all interchangeable with the rest of your models.
So has AutoCAD improved the interface for their
This is a new product. This is a new product now. They acquired Alice Labs.
Because the old one was very buggy
Yeah.
and really slow if you had too big of a point cloud.
Yeah, I'm not going to say it's not buggy, but it's a new product. We all know better than that.
You got a question up there.
I'm sorry.
LiDAR collection, was it stationary or was it mobile?
These were all ground-based, or stationary, yes. It was a Faro. We like this, in being a visualization group, we're really interested in this, these scans that collect the RGB data as well, because you get a real, almost visualization quality model from the scan directly. So here's what it looked like when we got it from the vendor. You can see all the snippets of cars. He was doing this during the day in heavy traffic, so when the scanner would go around, he'd get artifacts from cars passing by. But by, selecting the right viewpoint and cropping data out, I could quickly clean that up. This took me about 2 hours to get it to this condition. So the tools are really moving ahead in this way. And one of the things we've been sort of thinking about is, rather than looking at feature extraction as a way the industry needs to go, maybe we just need to have tools that let us use the point cloud more efficiently and just use the point cloud as your as-built conditions, instead of having to go through all these hoops to pull geometry from it.
What was the size of the point cloud scan?
A few gigs. I don't remember exactly.
I don't mean that way. I meant how many points, because you can select most of the vendors, the size of the density.
Yeah, it was Faro, whatever he did them on a 50-foot, or not a 50-foot. He had a process for how he picked his spacing, trying to get us, I think, close to an inch if he could. There's a spec in his proposal, and I don't remember exactly what it was, but that's the critical thing, is that know what kind of data you're expecting from the vendor and specify it.
And again, that's the challenge. Where do you get that information? How do you know that? Sometimes you gotta learn the hard way, but typing that in Google might get you that answer.
Well, and we have
Probably
some
not.
people who are actively looking at point cloud tools, even as we speak. So Chris from CH has been doing some interesting research on that. And we have somebody who's been doing something very similar. And then Lance Parve from Wisconsin actually published a document that kind of describes some of the differences between aerial, mobile, and ground-based, and what kind of precision or accuracy you could expect and how to specify it. I don't know if that was ever published, but it was a nice document. So we have 15 minutes. I'll try to run a couple models here just to give you an idea of
Yep.
what these look like live.
One more question.
Yeah.
You probably answered this well running the model, but I was just wondering how long the one project you just showed was, and how many people you really had working on it.
Which project?
Size of the team, the big one with the day.
Well, there were several different things on that project. We had one person just doing model conversion. He worked, it was, let's see, it was about 800 hours to do the conversion from our max model to InfraWorks and get all the data put together and to produce the model. And that included cleaning up the two bridges and doing a lot of the work on market. I'll show some of this stuff here in a minute. This is kind of the lowest end model. Again, we typically do this and send it out to the team right away. This is just an aerial and a terrain, and then a real simple 3D model that we produced, in InfraWorks to show the bridge, just to be used as a planning tool. So people, when they're talking about the project, they can be talking over something interactive and, a little more a good reference of the site. So for planning level, it's a great tool, especially with these really lightweight, simple models. It's like Google Earth pretty much, but it's a separate tool. I'll show the San Francisco. Oh, before I do that, one other thing that we kind of liked about it, we're doing a lot of projects for Caltrans, and so the tool set, or the style set that comes with InfraWorks, it was developed overseas, so it didn't really seem to fit well with projects we were doing in the U.S. So we created our own library of styles. And what styles are in InfraWorks is if you have a line, a vector representing a road corridor, you can just apply a style to it and it generates 3D geometry for that corridor. So we created several styles based on Caltrans design criteria. And we also added some of our own texture maps. We liked our our asphalt texture map a little bit better than theirs. But it's a nice feature, and it kind of like Chuck's building engine tool, this is sort of a civil object creation tool that we've customized for our own uses. I think we even have some chain link in here somewhere. We have railings. We have some typical barrier and sound walls. Somewhere I thought we even had a, chain link rail. Well, trust me, one of these has I was looking at it earlier thinking, wow, we actually did chain link on this thing. So this was just our little model showing how this would work as a bridge and how the different styles would work. You can set numbers of lanes, median widths, all sorts of things in the definition of the object.
Trouble with combined scale factors, using grid to,
In InfraWorks or?
in general, bringing in the aerial imagery,
You have to know what coordinate system it's in, but typically geospatial data, if it's in a known coordinate system, it's usually, that's why we use either GeoMapper or InfraWorks directly, is we don't want to scale it in any other. We've used Civil 3D, Map 3D to do that a little bit, but it's much easier in these geospatial tools to rescale stuff if you need it in a different coordinate system. Let me start this load here. While this is loading, other questions or?
the program you said using Geo?
It's a tool called Global Mapper from Blue Marble. It's a nice tool. This is the model I showed yesterday, but what I've done is in the model settings, you can set a clip. So in this one, I set a little polygon clip, and now it's running much smoother than the giant model was yesterday. So it's still loading, but this is the kind of the downtown Market Street part of the model. And again, we do a couple of things for our own benefit. We really wanted to dress up this area. This is the end of Market. Autodesk is in that building at the end of the street. This is still the original aerial, but if any of you have worked with urban aerial data, there's always shadows and all sorts of junk in the image. We will typically have a painter, we have some very fast painters, load them in Photoshop and clean up some of the shadows and that sort of thing, like down here on Market Street. And at one point, we even considered re-rendering the actual Market Street striping because it's so rough. But if I move farther down Market, you'll see where we didn't do the paint work, you have these huge shadows. Now, if we were to turn the light of day on to the same time of day as the shadows, you could probably get it to not be so obvious, but just those kinds of things bother us. And as Chuck said, you can see the difference in the aerial textures. In the building textures. Some of them were a little nicer than others. If you come out here and get to a distance, it looks great. But if you wanted to do something looking at a design down in the project, you'd probably want to take that one building and up-res the building textures either through photography or paint or some sort of technique.
Kevin, were those 6-inch pixels to begin with?
I think the aerials in the city were 6-inch, yeah. The stuff we got from SF. And I think we had a DEM from them, but sometimes things get changed downstream and unless I go back and look at which set it was, we tried to name the aerial sets based on resolution, but I think that got lost in the process somewhere. Let me turn off the buildings and we can go look at those more closely. Everything's tiny here. The other thing I like about InfraWorks, we talked about LOD. You can do custom LOD settings, but it also has its own built-in LOD setting. If you turn on a little switch on a layer here, it does automatic LOD switching on the aerial textures. And then if you have geometry, it tries to do its own automated LOD reduction on geometry, but we haven't found that to really be very effective. I think the thing you would want to do is, if you have an area where you have a lot of geometry, is as Chuck said, spend the time and do some geometry switching. So I've got, I think the buildings are on the buildings layer. Oh, that's the geospatial buildings. I wanted to show the it has another nice little feature for custom buildings. There we go. So I'm going to turn off the 3D modeled buildings, then we can get a better look at the aerials. Yeah, that's probably 6-inch, I think. So there you're seeing the aerials directly, and then if I zoom out to the outside of where we had built 3D geometry, it has another fun little feature where if you have shape files for buildings, in this case, this came from the city, and they had an attribute on the shape that had the number of floors in the building. So we could set up a little script that just multiplied the number of floors by 10 feet, I think it was, or some metric equivalent, and created heights for the buildings outside of the main part of the city. You could also apply a random color texture, and they had a color palette that was taken from the aerial photograph, so the colors being applied to the buildings are a library of colors taken from an aerial photo. So the rest of the city is all based on this auto-generated 3D building data set. And then if I turn the buildings back on, I can give you an idea of what one of these things look like. We can check the properties on it. Oh, I must have it locked. Nope. I don't know why I'm not able to select the building, but it also has a tool where you can go in and examine each, there we go, each little building. Yeah.
So everything's static, right, in this, moving around, moving the camera around, there's no people, there's no cars, there's no trains. And so I do a lot of work with traffic simulation, and my tool and all the other vendors' tools have a 3D piece to it, but they're all pretty crude, right? The renderings aren't so great, but everybody likes to see that. So how easy, or do you know of any projects where people have taken, say, trajectory data out of a traffic simulation or out of a transit simulation and overlaid on this, or imported it? We've done some things with 3D Studio Max to just show things moving, but
Yeah, we've done that.
small models.
Yeah, you can do it in Max, but I don't think there's no animation support in InfraWorks yet. You know, they're threatening to do something, but not at this point.
We've done it, and the University of Buffalo folks are here. They've used their runtime engine to integrate VisSim into a real-time environment. Have you guys gotten it to work in Unity yet? Or?
Yeah, we did Unity, I think.
Okay, so they can do Unity, bring in a VisSim model as well.
So are they running both at the same time, or is it exporting from VSim?
Yeah, it's exported and then I'm just replaying.
And you're playing it back?
You're using an FCP?
Yeah. Yeah, we use VisSim directly in real time, so it's not an export. And the driving simulator, that always drives. Keynote, that was the example.
So good news, there's multiple ways out there.
So you pulled it in real time?
Yeah, but we did programming to do that. I don't know of any tool where the vendors have given you that, and that's our own system that we program.
I was going to try to open up the whole model, but I'm probably playing with fire.
But I know in
here.
Unity, you can add separate animation into a virtual environment. So as you're moving around, it could be people or vehicles or trees moving or whatever else it is you need to do. We did a virtual model for a large corporate client to show how a machine worked. And we actually mimicked the process of the machine. So everything functioned in sequence, but we were still in a real-time environment. So you certainly can do those type of
Limitations on the number of objects?
Pardon me?
Limitations on the number of objects? I'm talking about animation. Thousands of vehicles, hundreds of thousands of vehicles,
We have 100,000.
100,000?
Is that the limit, or that's as much as you
That's what
pushed?
we tried.
Okay.
The real-time engine between this and they limited it to 1,000 because of how much they can export in real time. With bigger processors, that number can go up. As technology changes, but there is a limit to the amount of streaming we can do.
If you want to come down afterwards, I can show you a demo of one that the UB has done.
Just one last model. We're starting to build a model of California just because we want to be able to look at some of the corridors being proposed for California high-speed rail, and we're just curious, could you actually have detailed SIDS files for the whole state and load them all up? I've started rebuilding it into two models, Southern California and Northern, because the other one takes 10 minutes to load. But you get pretty rich sort of corridor, regional level views. And I think this is 9th arc-second DEM data and meter aerial data, which we now have for the entire state.
Again, I want to stress that we've shown you some of the tools that we're using. There's many, many more out there, so don't think these are the end-all tools. I mean, I haven't mentioned GeoWeb 3D and a bunch of other really nice tools that you can use. So they're out there. You just need to find out which one works best for you.
So that's what I had. Any other questions?
Yeah.
When you update attributes or update geometry in InfraWorks, do you have to rebuild the model, regenerate the model, or is it do it on the fly?
Yeah, no, you have the option of hitting regen, because if it has to regenerate something that affects an aerial, it rebuilds the aerial. It's got this complicated tile caching system, which is local. So if you regenerate it when you're online, you can then take the model away and run it locally. And the tiling system is managed locally by the application. If you change something where it needs to update an aerial in the model or terrain in the model, then you have to reconnect, get access to the original source, and it'll regenerate from that source.
I was thinking more like roadway geometry or something.
It's not a live link, no.
So we use older version of it. This 2014, is it ready for prime time now?
InfraWorks?
Yeah.
Depends on what you want to do with it. I think in terms of managing, aerial DEM data and 3D models to a certain degree, it's pretty stable. But the vector stuff, if it's a lot of vector data, that tends to slow it down. But we've been throwing some pretty big models at it, so that's probably not helping.
If you're interested in this technology and you want to participate more, the Visualization Committee has a subcommittee called VDC Sim, and we're meeting in 5 minutes in the boardroom. You're welcome to participate as much as you want or as little as you want. Right now, we're a core group of 6 of us, so we'd certainly like to have other folks participate. Chris is here as well with Kevin and I. Lance couldn't make it, or Phil Bell from New York State DOT, and Maria Chow from FHWA are the other 3 members. And we probably get together every 6 to 8 weeks over the phone, talking about what we're trying to do. And as Kevin mentioned, Chris is investigating LiDAR technologies and sharing that information with us. And we certainly need other folks to participate and pick other areas of focus as well. So you're welcome to join us.